Good afternoon, everybody. Today we will deal with, in continuation with design patterns, a type of design patterns called behavioral design patterns. In that, we will see one which is an iterator pattern. Behavioral design patterns correspond to the algorithms and assignment of responsibilities between the classes and objects. It is mainly concerned with the communication between the objects. We have behavioral class patterns as well as object patterns. Class patterns deal with the object oriented concept of inheritance to solve the problem, whereas the object patterns deal with the composition or the structure of objects and the messages passed between the objects during runtime for the solution of the problem. One of the object behavioral patterns we will see today is iterator. Iterator is a pattern for the problem where we have to access the elements of an aggregate object without knowing how the aggregate object is composed and how it is structured. What is that aggregate objects? Aggregate object is the object which contains a set of elements which are connected together, and this aggregate objects can be any aggregate objects like a list, or it may be a set of nodes which we call it as a graph, or a tree also. That is, these are the examples of aggregate objects. We have to access each element of the aggregate object without knowing how the elements are interconnected and how they are composed to form an aggregate objects. How to solve this, that we will see using an iterator. This pattern is also known as a cursor. The main motivation also comes from the same, that is, without knowing how the composite object is represented, we have to access each element of the composite object. Then we can have an iterator, and we solve this problem using different types of iterator also, which we will see, which in the structure and implementation, and we will address how we can solve different traversals and how we can have different iterators also. The application of iterator is to access the element of the aggregate object, and where we can also access each element in different way, which we call it as multiple traversals. We will see first how this design pattern has given the solution. First, the contents or main elements and participants of the iterator are the aggregate and iterator. Aggregate here is our composite object, and iterator is the class which will be solving our problem. Client is the application which we are using for aggregate also, and to access the elements of the aggregate. The client or application uses the aggregate, and aggregate internally uses the iterator for the traversal, or the client can also use iterator for traversals. So the application, mainly here it is client, shown as client or application using aggregate and using iterator. The concrete aggregate here is the composite object which is derived from the abstract class aggregate. The iterator concrete, which is concrete iterator here, is derived from the iterator class. The concrete aggregate example can be a list or a type of a list, or it may be a group of object which contains a set of elements. The iterator is the class which will traverse this composite object in many different ways. Here, there are some operations listed for iterator. Those are first, next, is done, and current item. These should be at least the minimum operations for iterator to access the concrete aggregate or concrete aggregate object. The collaborations here we will see between the application and aggregate, application and iterator. Also, the collaboration, that is communication, is between the relation is between the composite object and the iterator, because the application has to access the elements of the aggregate without knowing how we will be accessing each element of the aggregate using the iterator. Iterator has first, next, is done, current item, which will be accessed by our application, and this iterator should work on this composite aggregate. So there should be a relation or a link between iterator and the composite object, and which is shown here with the delegation or with the link and association between the concrete iterator and the concrete aggregate. How this association is interpreted is whenever here there is a factory method called as create iterator. Factory method is what we have seen is to create a set of objects using only one interface, and here it is create iterator. Create iterator will be creating an iterator object, but that whenever we create the iterator, we have to know for concrete iterator object, we have to know which aggregate it is connected to, so that it can access elements of that aggregate object only. So we have one list, then each object of the list will be concerned or linked with one object of concrete iterator. So this create iterator will do that function. It will make a concrete iterator object and new concrete iterator object, and also link this in C++ is concerned with the current object, which is my concrete aggregate object here. So create iterator will create the iterator object and also link the current aggregate object to that iterator. So the iterator is concerned only with that aggregate object. Whenever we from the application, it is called with first, next, is done, or current item to access the iterator. This is a general solution where we have iterator, concrete iterator, aggregate, and concrete aggregate as the elements of the iterator design pattern. This we will see with the example to clear how it will work. Here, the aggregate object we are taking is a list. So we have a class abstract list, and it can have all the operations of a list, from it may be creation of a list, count, append, remove an item, and so on for the list. But in addition to that, we have a create iterator operation. this operation, as we have seen in the previous structure, it is giving me the object of iterator. So as this is abstract, we are deriving from this and creating list. Here we are seeing what we have seen in the motivation, that is multiple types of list as well as multiple types or hierarchy of iterators. We can have different types of lists, which can be a list or a skip list, which is derived from abstract list. Each can have its each can have its own sorry, each can have its own iterator. So iterator is derived from the iterator abstract class, which is list iterator, which is connected with list type, and a skip list iterator, which is connected with the skip list. So the create iterator of list will create the new list iterator, and create iterator for skip list will create new skip list iterator. But list iterator and also skip list iterator will have the operations first, next, is done, current item to traverse the list or the skip list respectively, accordingly where it is connected to. So we can have the types of iterators also on the types of aggregate objects. Here there is only one iterator is concerned with one type of list. We can have more than one type of iterator for a list also. Here there is only one list iterator and skip list iterator. We can have backward list iterator, we can have forward list iterator, we can have the skip list iterator also, like forward skip list iterator, backward skip list iterator, so that we can have multiple traversals on a single aggregate object. This is how iterator will solve the problem of the accessing the element of an aggregate object without knowing how the list is formed and how the skip list is formed. It knows only first, next, and the operations without knowing in detail the representation of the list or the skip list. The application will only call the first, next, is done, and these operations. It will not be accessing how the set of elements are inside the list or a skip list. In this way, iterator solves the problem here. Some implementation issues also we will see here, and the main collaboration is between the iterator and how it keeps track of the current position of the aggregate object. So the main consequence we have already achieved, that is to solve the problem of without knowing the contents or representation of the aggregate object, iterator will solve the problem of going through each element of the concrete aggregate object. Some implementation issues we will see here, that is with the types of iterators also we can solve, as well as through some object oriented concepts. We have two types of iterators, external and internal iterator, depending on which class will control the iteration. So external iterator, the application will control how you traverse each element of the object, which is aggregate object. But if we want to have the iterator itself control, then we will have internal iterator, where it will decide which will be the next element, which will be the is done element after completion of accessing, and everything will be controlled by the iterator operation only, and application or the client will just access that operation. We can also define different traversal algorithms for iterator, as we have seen. For the types of iterator also we can define for different algorithms for iterator. Iterators can define the traversal algorithm. So the algorithm which we have defined for our accessing can be inside the aggregate object, or it can be inside the iterator object, in the same way as we have external or internal iterator. The iterator is robust when the list or the concrete aggregate object is updated, or like inserting an element or deleting an element. Then also the iterator will not be affected by this update operation. Then we call it as robust iterator. But minimum iterator operations, as we have seen in the structure, it should be first, next is done to check the end of or where to stop our accessing, and also to keep track of which is the current element of the concrete aggregate object which we will have to access. And we can have types depending on which additional things we need for the iterator operations. We have polymorphic iterators, so that we can have types of iterators, and these iterators again, the operations will be redefined in the types of iterators, and these iterators can also be destroyed by either the client here or using other iterators. We can have the iterator access to aggregate object, which we call it as the friend of the aggregate. That means the iterator object can access the elements as well as the structure of how the elements are connected inside a concrete aggregate object. Then we have to make it the iterator as a friend of aggregate. This is how we can apply some OOPS concepts. Iterator, if for the composite or a complex aggregate object, then the external iterator is very difficult to implement. That means the client may not be able to do all the accessing on itself. So the responsibility of accessing will be on the iterator itself. In that case, then we have to go for internal iterator. Then the internal iterator, which if the responsibility is on the iterator, we can also implement different traversals for the composite object. And the boundary conditions of the concrete aggregate object can be handled using the iterator, which can be assigned null. So whenever we have at the end of the concrete aggregate object, which is given by is done operation, which is returning either true or false, then we can have a null iterator at the end of the concrete aggregate object. There are different other uses of, or the known uses of this, which we have already using and implement already. A standard template library of C++ uses iterators. It has already defined and we are using it in our applications. Java JDK API also has iterators. Many programming language APIs will now have iterators on concrete aggregate objects like lists, different types of lists, or it may be graphs or trees. So the related pattern to this iterator can be composite, factory method, or memento, where here factory method, where we have seen as create iterator, which is a factory method which will create depending on the type of iterators, which we call it as polymorphic iterator. And this is the main use of iterator, which we have seen how it solves using object oriented concepts of inheritance and delegation, but also it will be using the structure of what we call it as abstract iterators and concrete objects. That is one more concept of oops. Thank you.